Hello, I'm Anna Mackay, and today we're starting a new topic on growth and decay, and we're starting off by looking at surds. Okay, so some definitions here. A radical is any number with that square root sign, and a surd is any real or irrational radical. So for example, we've got root 2, root 3 and root 5. What about the number of root 4 though? Is that a surd? So it's a radical because it's got the square root sign, but it's not a surd because what's the answer to root 4? That's 2. And that number is real and rational. So essentially what we're saying is that if the number under the square root sign is not a perfect square number, then you have a surd. Those numbers 2, 3 and 5, they're real numbers, and so they define as a surd. And if they've got the square root sign, it's defined as a radical. So root A is never negative. So that means the answer that you get from square rooting the number, that answer can never be negative. So for example, the square root of 4 is positive 2. We can't ever get negative 2. And some of the index laws here, which we're going to go on and do a bit later, is root A times by root A. So imagine if you had root 4 times by square root of 4, what would you get to that one? You'd get 4, so you would get that A, whatever the number is. And if you have root A times by root B, so different numbers there under the radical sign, it's the same as putting them both together under the square root sign there and multiplying them. We're going to go into index laws more in the next video. And this other rule with the division, it's the same as if you put the square root over the whole fraction. Okay, so if we're asked to write some things as a single surd, root 2 times by root 3. So based on the rule over to the left here, that says if we've got two square roots, we can write them as one combined. So you would write 2 multiplied by 3 and the square root over all of that, and that works out to be square root of 6. Next, if you had root 18 over root 6, based on the rule bottom left-hand corner here, that's the equivalent of 18 over 6 and the square root over all of that. And that comes out to be the square root of 3. And here, if you're asked to write root 18 in the form of A and square root B. So essentially what you would start looking for is within 18, can you find two numbers that would multiply together to give 18? Yes, okay, you could have 6 and 3. Now the thing is with 6 and 3 though, is that then if you use the surd law and split that, which we'll go into more depth later, the thing is though, you don't have a whole number in this form here. You've got two surds, and that's not quite what the question is asking. So when you get a question like this, the aim is, well, with any square root, is to look for a perfect number that can go into that. So what I mean by that is 1, 4, 9, 16, 25. And in 18, can you see any? Yes. You would have 9 times by 2, 9 times by 2. And then you can split your surd. So you would have root 9 times by root 2. And the square root of 9 is 3. And so we have 3 root 2. And now that's in the form A square root B. Okay, and because the question went on to actually ask us where A and B had to be integers, and A had to be as large as possible. So that's the version that we've got. Just a note on simplifying. So when you come to surds and collecting like terms almost, if you had to do this one, 3A plus 2A. So that's 3 apples plus 2 apples. How many apples have you got? You've got 5 apples. So the same concept applies with surds. If you had, for example, 3 root, make up one, 7. So instead of an A now we have root 7, and we're adding on 2 lots of root 7. What do you have together? You have 5 lots of that root 7. So you don't multiply those 7s together, you don't square them, you just collect like terms. So let's put that into practice. So multiplying this bracket out here, so we're using the distributive law, so you have to distribute that root 5 to both terms inside. I'm going to write it out the long way while we're practicing this in early days. So we've got root 5 multiplied by root 6 and then root 5 multiplied by root 5. And I'm putting the negative sign in here. Simplifying that, 6 root 5, and then root 5 multiplied by root 5 gives us just 5. So our final answer is 6 root 5, take 5. Using FOIL, first outers, inners, lasts, so you're having to multiply out. So we have this 6 multiplied by 1, so we get 6. Then 6 multiplied by 2 root 3. I'm going to write this out the long way to start with, but you'll get quicker with practice. Don't mind the bell there. Next, we have this root 3 multiplied by 1, and then root 3 multiplied by 2 root 3. And now we're going to simplify a bit further. The 6 stays as a 6. This 6 and this 2 get multiplied together to give us 12 root 3. The 1 root 3 here just stays as one lot of root 3. And over here, think what happens. Root 3 multiplied by root 3 gives us 3, just the whole number of 3, and then that 3 needs to be multiplied by that 2. So we've got 6 at the end. And then collect like terms. We have 6, add 6 to give us 12, and then we've got 12 lots of root 3, and how many lots of root 3 here? 1, so we've got 13 lots of root 3 all up. You might ask, which order do I write them in? Do I write the whole number first, or do I write the section with the surds first? It doesn't really matter, but one of the general forms that we do these things in is with the whole number first. Okay, another one. What does this look like with the square here? You've seen that before, a perfect square. So we know that we have to square the first term, so 5 squared, and then square the last term if you like. So we'll do that first. Root 2 squared. Now inside, noticing that it's a subtract, so we put that take there. It's 2 lots of the first term and then the last term, so root 2, and then it's an add on the end. Simplifying that, 5 squared, 25. Subtract, now the numbers multiply together, 2 times 5 gives us 10, and then root 2, and root 2 squared is root 2 times by root 2 gives us 2. Collect like terms so we can work with the constants. 25 plus 2 is 27, take 10 root 2. Next. So you may recognise this as what would end up being the difference of 2 squares when we expand it out. So that the middle term would disappear and you're just left with the end terms. All right, so working on that one. So we have the first terms squared, so that's 7 squared, and then a subtract. And then we look at the end terms and square that. Working that out, 7 squared is 49, and then you must square both components here. Please don't just square the root 5. The 2 needs squaring as well. So 2 squared is 4, and 5 squared is 5. Sorry, root 5 squared is 5, and that works out to be 49 subtract 20 equals 29. Okay, join me in our next video for division by surds. Thank you.